Hey guys, and welcome to Cloud Teaches Everything. This is just a little show that I decided to start for fun, where I try to teach people that I know or random people from the audience different things on any topic, pretty much any topic at all. So today we have Benny or Kara underscore Dreamer. He is a 3D modeler and he modeled pretty much everything for me up until now. And he's going to come on and try to learn calculus.
I hate my life.
Okay, so the way this game is going to work is I'm basically going to use Google Drawing and just explanations to try and teach him the basics of calculus in the most basic of basic senses. And you guys can try and learn too, but it's going to be very difficult for pretty much all of us. So let's get started already. I have a limited time, and at the end, he's going to do some quiz questions. And depending on how many he gets right, that's basically my score and his score combined. That's our total score for the episode, and we're going to try and see who can get the highest score out of everybody that comes on the show in the season. I don't know how many episodes I'll do. If you guys have any suggestions for other topics, this one he just chose because he hates himself. But if you guys have any suggestions for other topics, go ahead and leave a comment in the description. If you want to be a part of the show, leave a comment in the description. Leave a comment in the description. Leave a comment
Good English.
in the comments section, and I will try to include as many people as I can as long as you have a decent mic and are available. I'll try to include you, but for now, I'm just doing people that I know are available. But anyways, so let's get started on calculus. Definitely not the thing that I wanted to teach today, but we're going to get into it. Benny, what do you know about math so far?
Yes.
Yes. Okay, so he knows yes. That's all the math he's taken in school so far. He's taken yes.
No, no, no.
So
Geometry.
okay, so you know up
Geometry.
to geometry, which
Geometry
is
and the other thing. Crap. What it's called? Ge- God, I forgot the names.
algebra.
Oh, that's the name.
Okay.
Algebra.
Yeah.
I
So
took in
geometry.
trigonometry. I actually took rocket science.
Yeah, you actually took rocket science at
Yo.
NASA School of Engineering. Totally
Yeah,
a
no
thing.
idea.
Okay, so
Pretty
I'm gonna
great.
pull up the Google Drawing here.
Yeah.
There we go. Okay, Google Drawing. Not as many important. Actually, okay, yeah, Google Drawing. Not as many important things to see here. We are going to. I'm just gonna face the board so you guys can see what's going on at the board, and at the same time, I'm gonna go into Google Drawing and give Benny permission to view only. So basically, the most important part of calculus is figuring out based on the position something goes. You want to find the velocity, or based on the velocity something's moving, you want to find the acceleration. So an example that is often used is you have a ball and you are shooting it, throwing it up in the air. After a certain point, it's going to go up, and then after a certain amount of time, it's going to come back down. So to in a graph, if you want to explain this motion of a ball going straight up and straight down in a graph, you would graph it based on time. So at 1 second, it's at 10 feet at right here. At 0 seconds, it's at 0 feet. Then at 30 seconds, at 30 seconds, it's going to be all
Great
the way
drawing.
up here, right here, and vice versa. So it's just going to go up and it's going to go down. So let's just draw the graph for this, which is really bad. And boom. Okay, so that's the graph of it, Benny. You see that?
Yeah, don't
So
quit your daytime job.
yeah, you're right. So over time, the ball is going to go up and then back down. This just graphs its position over time in the y direction. So it goes up to say 50 feet and then down back to 0 feet, which is where your hand is. So at
Sure.
this instance right here, Benny, this where right here where this right where my square is right
Yeah,
there.
I see. I see. I see.
That's where the velocity is equal to
0.
0 meters per second because it's at the top, so it's maxed, and it's going to start going down, so it's going to return down. So the derivative, which is the first part of calculus, is trying to find a graph to represent this change, which the graph of this would be something like that. That's going to represent how the velocity changes over time. So
Sure.
at time equals 0, your velocity is 0. Of course, this graph can be changed depending on many different factors, but as time goes by, your velocity either increases or decreases. It can go down. You can have all kinds of shapes of velocities. You can have changing velocities like that. Blah, 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 blah. Okay? Okay.
Wow.
Very, very much good.
Mosaic art right here, mate.
Okay. So we're going to ignore that because that's physics. So we're going to talk about the math part because that's calculus. So the
Math.
equation for that, for a right side up kind of U like that, which is a parabola, is x squared, okay? What we want to find is the derivative of x squared, which is d dx of x squared. That's just something they use as like a, I'm taking the derivative of this. You know, it's like a math operator. It's like you put a
Oh.
times next to something if you're trying to multiply something. This is derivative symbol, okay? d dx means you're taking the derivative of this, okay? So
Sure.
when you're taking the derivative, you take this number here and you multiply it at the front like that, right? So now you have 2x squared, right? That's step 1.
Uh,
Okay, you brought this down. Then step 2 is going to do subtract 1 from the exponent, like that. And your answer is going to be x to the first times 2. 2x to the first. Okay? So Benny, what's the
sure.
first step?
Yes.
Yes.
No,
Okay,
no.
what's the first step?
Bring the exponent to the front of the x.
Yes.
-1.
Yes.
There you go.
There you go. Okay, so let's do the first problem because there's 2 practice problems. Let me get rid of the thing. Okay, so here we have 5x to the 4th. So go ahead, Benny.
I gotta zoom in. Oh. Okay. So from the knowledge you taught me right here in Google Drive, so I gotta bring the 4 to the 5 times it, so that'll be 20x to the power of 3.
Yes. Okay, so that one is good.
Oh,
You're good.
I'm a god, yo.
Yeah, you're so amazing, dude. Answer 20x to the 3. Okay, so we're going to go on to the next one. This is the harder one, which is x to the 1/2 plus x. So what I'm trying to say here, this is just a special note. Let me do a selector and get rid of everything there so I can have some room. So I'm just going to keep the side thing for you. So when you have something like x to the 1/2 plus x, when you want to find, when I tell you to find the derivative of it, I'm saying do this. Ready? You see this? Just like before,
Oh, it's kind of slow.
d dx, the derivative of that equation. You see that? Did it update
Alright,
yet?
DDX.
d dx just means derivative. Okay?
Got it.
So the derivative of that whole equation, the derivative of that whole equation is also the derivative of the first one plus, the derivative of the second one. Now that it's split up, it's easier to do. Okay? So what's the derivative of the first one? Of the second one, because the second one's easier to do. What's the derivative of the second
Alright. So if I put, so be 1x to the power of 0.
one? Which
So
is?
x will be 1.
There you go. Okay. Second one,
Okay.
this one is a little bit harder. Now you have a
And
fraction.
that's on my paper. Okay.
So you,
So if I put that, that'll mean 1/2 x minus 1, so that'll be -1/2,
yes.
right?
Yep. That's it.
So it'll be,
That's it.
uh,
There
wait,
you go.
wait.
Look, that's the answer. 1/2 x to the negative 1/2
Plus
plus
negative
1
1/2
plus 1.
x to 1/2.
So now we have the graph of the velocity. So this is how the velocity changes over time, right? There's your
Sure.
velocity, your graph for velocity. So that's at
Pretty
time
straight.
equals 0, velocity is 0. There's your y-axis. So you're going up and down, and it's changing speeds as you go up and down, right? So time equals 0, y equals 0, blah, 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 right? Time velocity, blah, 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 time velocity, right? Okay. So now with antiderivatives, we're doing the opposite of what we did before. So we want to turn that thing into something more complicated like this thing, right?
Why do we want to do this?
Because if we have something that, if we know the speed of something, because oftentimes you know how fast something's moving, you can, using this kind of antiderivative equation, we can figure out where it will end up. So if you have the speed of the ball as you throw it up, or the speed of the ball as it's going through the air, then you can
Uh-huh.
find out where it will land or how high it will go. Okay?
Okay.
But that's physics, so We're not going to do the examples that are questions, like real problems. So we're going to talk about what antiderivative is. So the symbol for it, oh, and let me move out here and look like this, just for you. Okay, so
Yeah.
this is what it is. So some function there with the integral symbol, and then dx. Notice how
So
here we have the
S.
dx again, but instead it's multiplied and it's not divided. It's just a different way. This is just how they like to say doing the opposite of a derivative, okay? You
Alright,
don't need
smart
to,
people being
just like
dumb.
before, you see where it says d dx, and all we did
Yeah.
was that is just telling us to do the 3 steps and we just ignore it. Same thing with this one. The
Sure.
symbol in the dx is just telling us to do these next 3 steps and ignore it. So the
Okay.
first step is going to be, and let me clear this because I'm just going to, I want to make it a lot smaller so that
Wait. Just to make that sure, was that an S or a squiggly line?
it's like an S, but the center is really long. Like the really good way
Okay.
to do it is like this. That's the good one, but I do it fast.
Alright, so basically a fish hook. What does
Yeah,
that represent?
that just represents the antiderivative. That's the integral symbol, but I'm not going to describe
And
integrals because integrals are complicated. So integral of x. So basically, we're going to go x, right? We're going to go step 1.
yeah,
You have x, and we're going to do the opposite. Our first step is going to be messing around with the exponent. So we're adding 1 to it. Okay.
sure.
Then our second step, now we have x squared. We're going to take this and we're going to move it down, way down here. Oh, I should make that look like an arrow. So we're going to move it way down here, right? To make it x over 2. Answer, x squared over 2. Got it?
So wait, so it'll be x1 plus 1, x to the power of 2, and then that'll be moved to the denominator. It will be x to the power of 2 over 2. Got it.
Yes, I'm going to move these things over here.
And that's for the antiderivative stuff, right?
Yes, yeah.
Okay.
So it's really important that you add 1 to the exponent. You mess with the exponent first, then you bring it under. Okay?
Alright.
Now, notice also, watch this. Up here, sorry. What's d dx? So we got this new equation from our integral, which is x squared over 2, right?
Yes.
So what is d dx of x squared over 2? The
Alright, so
derivative.
we have
Go through the steps. First
d
step, you
dx.
bring it
Okay.
down.
Alright, so I gotta bring that down. So it'll be x3, right? X to the power of 3.
No, we're doing the derivative. So this is the first set of steps. These steps.
Oh, okay. So it will be 2x.
Okay.
Alright, wait, let me write this down on my paper. Wait to show you this. It's gonna be fun. You're gonna be like, what the heck?
Okay, ready?
So it'll be 2x and over 2. That'll be the derivative. Okay, what else?
Which equals, like simplify 2x over 2.
That will cancel each other out, right?
Yeah.
X.
And guess what? Look at this.
What?
Your answer right here is x, and what did we start with up here?
X plus 1.
No, just up here. Sorry, before we took the integral of it.
X.
Yeah, x, 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 x. All we did
Oh
was
my
we took the.
gosh.
Yeah, so that's how you can kind of check if you got the right answer. So if you take an antiderivative, if you want to check to make sure it's right, take the derivative of it, and if it equals what you started with, then you're good. X is x, so we did the integral right. We can go back and
Huh.
forth. That's how they work. You can go back and forth. You can go velocity, then it turns into an position, and then you can turn position back into a velocity. Good?
Man, I can't wait to take calc.
Okay. So now we're going to go on to an example.
Hate my life.
Next problem. X to the 7th. And this one I'll write on the board here. X to the 7th. And I want you to do the integral of it.
Alright, so that'll be 8.
Okay.
And then I gotta bring that to the denominator, so it'll be x8 over 8.
Awesome. Yep, that's it. X8 over 8. And if I click this here, There you go, x 8 over 8. Now the harder one. And this works the same way as the derivative did. So remember how we had, when I said take the derivative of the whole thing, you can also take the derivative of each part, right? So the
Sure.
integral of x plus x squared, see this?
Yeah.
You can also make it the integral of x dx plus the integral of x squared dx. Okay? So you
Okay.
can take the integral of the whole thing, or you can take the integral of each little piece.
Okay.
Okay?
I
So
understand.
now we have this new equation, which is x squared, x to the 2/3
All right.
plus x to the negative 4. Okay? So
All
first
right.
do x to the 2/3. What's the integral of that? Yeah. So x to the 5/3 times the reciprocal, which is 3 over fifths, which gives you
The answer.
x 5 to the 3 times 3/5. So 3/5 5x to the 5/3.
Okay. So I gotta add one because it's negative. It will be -3, right?
Yes.
All right. Good. 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 So you're telling me that's -3. Also, x -3. Next I gotta bring that to the bottom, so it'll be x over -3 with the power, and the x has the power 3.
Yeah. And then you put that all together, which would be x to the 5/3. And then add the 3 in the front. I don't have much space. Divided by 5. You see this? You put it all together, right?
Yes, yes, yes.
And since there's the negative in the bottom, it would actually be minus. So the 3/5 x to the 5/3 minus
Yeah, I know
x
that.
to the negative 3 over 3. Just like that.
Okay.
Okay.
So can we solve this or no?
What do you mean? That was it. You solved it. That was it.
Oh,
You can't find what
oh,
x is because what it does is it sets you up for a graph. It's just
oh,
giving you a graph. Okay?
dude, I feel enlightened.
That's why you can't solve for it. You can solve for it if you want to find like a specific place on the graph, like where it
Yeah.
crosses the x-axis. You said equal to 0, but we're not talking about that. So this is the practice quiz, Benny, the little quiz.
Oh no, is this the end?
This is the end. You got to do this. I can barely give you any helps.
All right. For this, I'm gonna be up here.
Dun dun
Fail.
dun dun dun. Okay,
All right.
2x to the 1/3, derivative of that. The first two
Oh,
questions
schnitzel.
are derivatives. The second two questions are antiderivatives. So the first two questions are the first 3 steps we went over. The second
Got it.
two questions
So
are the
want me to
second
find the derivative of this? So it'll be
Yes.
2x to the power of 1 over 3. Derivative is gonna tell me to put that to the front. So 2 times frick. 2 times 1/3. I have 2/3 x to the power of -1/3. Am I right?
Yep.
Hey, hey, Lamau.
You're good. Okay. Now the next question. This is the
Oh,
real
no.
one.
Oh, I hate you. I despise
X
you.
the derivative of x cubed plus 2x to the 1/4.
You really want to see me suffer now,
Remember
don't
what
you,
we
kid?
did, Benny. Remember what we
Alright,
did.
want me to find the derivative? Right?
Yes.
Okay, okay. So would it be 3x to the power 2 plus 1/2 x to the power of -1/4?
Are you doing your fractions right in that exponent, Benny?
The exponent of the last one, right?
1/4 minus 4 over 4?
1/4 minus what?
4 over 4?
Oh wait. Oh wait. 1. I hate you so much.
I'm only helping you with
Minus.
this because it's not a part of what I was trying to teach you. This is algebra.
Oh
One-
no, it will be 3/4. -3/4.
Let's see.
Alright.
Is that your final answer?
Yeah, that's my final answer. Oh, I'm gonna dab.
There you go, Benny. Now we're on to integrals, Benny. Integral of 2x to the 4/3.
Oh, yo, I actually like this right now. I like math.
Let's do it. Integral of 2x to the 4/3.
So it'll be 2x to 4/3. 6x power of 7/3 over 7.
Final answer?
All right. Yeah, final answer.
There you go. 6 to the 7/3 over 7.
Hey,
Last
look at
one.
that. I
Hardest
hate
one.
you. Yeah, I'm running out of paper here, mate.
Hardest one. Kill some more trees.
Okay, kill trees. Why is there a T? I didn't learn T. Okay, T is X. Never mind.
Dang it. I thought I could trick you there.
Yeah, no, T will be X. Anything can be used in the next one. I learned this from geometry. 2T for you, anyways. 2T over 3 minus 28x over 3. That's it. Right?
Yep.
Wait.
There you go. It's a plus because I
Sure.
accidentally typed minus in the question. It's supposed to be plus.
Hey, I won!
You did it. 4 out of 4. And
What
that's
did I
the
win?
end. You win the opportunity to make some puns. Go.
I need game mode 1. Well, Cloud, I gotta tell you something right now. I'm gonna make like a tree and leaf this place. You were really killing me to the bone. I wonder which exit I should go.
I'll show you the exit.
Oh, thanks. Oh,
Anyways, guys, if you made it to the end of this horror, leave a like maybe if you like puns. If not, I guess type spam Benny. Benny's puns are terrible in the comments.
wait. Before you do, look at me. Look at me. Ready? Hey, people from YouTube, why don't you leave a like? Get it? Oh.
Okay, we're out.